Space is vast and mysterious. It is also dangerous. One of the greatest dangers is invisible cosmic radiation. This radiation is energy. It travels through space at high speeds. It comes from the sun and from distant galaxies. On Earth, we are protected. Our atmosphere and magnetic field act as shields. They absorb most cosmic radiation. In space, there is no such protection. Astronauts are exposed to much higher levels of radiation. This is a serious concern for space travel. Cosmic radiation is a silent killer. We cannot see it or smell it, but it can have a devastating impact on our bodies. It can damage our cells and DNA. This can lead to cancer, other diseases, and even death. Understanding cosmic radiation is crucial. We must find ways to protect ourselves from it. Only then can we truly explore the wonders of the universe. Our planet is a haven in the harshness of space. This is due in part to our atmosphere and magnetic field. They act as shields against cosmic radiation. Like a blanket, the atmosphere absorbs most of the radiation. It prevents it from reaching the surface. The Earth's magnetic field also plays a vital role. It acts as a giant deflector shield. It pushes away charged particles from the sun and other stars. These particles are a major component of cosmic radiation. Without these protective shields, life on Earth would be very different. The constant bombardment of cosmic radiation would be deadly. Our atmosphere and magnetic field make our planet habitable. They are essential for life as we know it. However, even with these shields, some cosmic radiation reaches us. At higher altitudes, where the atmosphere is thinner, exposure is greater. This is why airline crews and frequent flyers receive a higher dose of radiation. The sun is a star. It gives us light and warmth. But the sun can also be dangerous. It releases bursts of energy and particles. These are called solar flares and coronal mass ejections. Solar flares are sudden, intense bursts of radiation from the sun's surface. They release enormous amounts of energy in the form of light, heat, and X-rays. While they can disrupt radio communications on Earth, they pose a lesser direct threat to astronauts due to their short duration. Coronal mass ejections, or CMEs, are much larger eruptions. They blast huge clouds of plasma into space. These clouds carry magnetic fields. They can travel at speeds of millions of miles per hour. When a CME hits Earth, it can cause geomagnetic storms. These storms can disrupt power grids and satellites. Astronauts caught in a solar storm are at risk. They can be exposed to lethal doses of radiation. The danger is greatest outside the protection of Earth's magnetic field. This is why space agencies carefully monitor solar activity. They plan missions to minimize the risk to astronauts. Beyond our solar system lies the vast expanse of our galaxy. It is a source of cosmic radiation that is constant and pervasive galactic cosmic rays, or GCRs. Unlike solar energetic particles, which originate from the sun, GCRs come from distant supernova explosions and other high-energy events within the Milky Way and beyond. GCRs are made up of high-energy atomic nuclei. They travel at nearly the speed of light. They are much more energetic than solar particles. This makes them much more difficult to shield against. GCRs can easily penetrate spacecraft and the human body. The composition of GCRs is diverse. They include protons, helium nuclei, and even heavier ions like iron. This heavy ion component is particularly concerning for long-duration space missions. They can cause significant damage at the cellular and DNA levels. The constant bombardment of GCRs poses a significant challenge for long-duration space missions. It is a factor that must be mitigated for missions to the Moon, Mars, and beyond. Section 5. The invisible threat. Cosmic radiation's impact on the human body. Cosmic radiation is a silent threat. We cannot see, smell, or feel it, but its effects on the human body can be devastating. The high-energy particles that make up cosmic radiation can penetrate our bodies and damage our cells. One of the primary concerns is damage to DNA. DNA is the blueprint of life. It carries the instructions for cell function. When cosmic radiation interacts with DNA, it can cause mutations. These mutations can lead to cancer and other diseases. The risks associated with cosmic radiation exposure are cumulative. This means that the longer an astronaut spends in space, the greater the risk of developing health problems. This is a significant concern for missions to Mars and beyond, which would require extended periods in deep space. the human body is remarkably resilient. It has mechanisms to repair some of the damage caused by cosmic radiation. However, these mechanisms can be overwhelmed by high doses or prolonged exposure. This underscores the need for effective shielding and other protective measures for astronauts. Section 6. The mind under threat: cognitive and neurological effects. The dangers of cosmic radiation extend beyond the physical body. There is growing concern about its impact on the brain. Studies on rodents have shown that exposure to cosmic radiation can lead to cognitive impairments. These include problems with memory, learning, and decision-making. The central nervous system, which includes the brain and spinal cord, is particularly vulnerable to radiation damage. Cosmic radiation can disrupt the delicate balance of neurotransmitters. These are chemicals that allow brain cells to communicate with each other. Astronauts on long-duration missions may experience a decline in cognitive function. This could have serious implications for mission success and the long-term health of astronauts. It is a risk that must be carefully considered and mitigated. Research into the neurological effects of cosmic radiation is ongoing. Scientists are working to understand the underlying mechanisms of damage and develop countermeasures to protect astronauts' brains from the harmful effects of space radiation. Section 7. A danger to technology: cosmic radiation and spacecraft. Cosmic radiation is not only a threat to human health, it can also damage spacecraft and onboard equipment. The high-energy particles can interfere with electronics, causing malfunctions and even complete system failures. One of the most significant concerns is the impact on spacecraft electronics. Cosmic rays can flip bits in computer memory, causing software to crash or data to become corrupted. These single-event upsets can have serious consequences, particularly for critical systems like navigation and life support. Radiation can also degrade solar panels, which are essential for providing power to spacecraft. Over time, exposure to cosmic radiation can reduce their efficiency, shortening the lifespan of a mission. Space agencies employ various techniques to protect spacecraft electronics from radiation. These include radiation-hardened components, which are designed to withstand higher levels of radiation, and shielding, which can absorb or deflect some of the incoming particles. As we venture further into space, developing more effective radiation protection for spacecraft will be crucial. Section 8. Shielding ourselves: current and future protective measures. Protecting astronauts from cosmic radiation is a top priority for space agencies worldwide. There are several approaches to shielding, each with its own advantages and limitations. One common method is physical shielding. This involves using dense materials to absorb or deflect radiation. Spacecraft are typically constructed with layers of aluminum or polyethylene, which can provide some protection against solar energetic particles and lower energy cosmic rays. However, physical shielding becomes increasingly heavy and impractical for higher energy radiation like GCRs. Researchers are exploring innovative shielding concepts such as magnetic shielding, which would create a magnetic field around the spacecraft to deflect charged particles. Another area of research is biological countermeasures. These involve developing drugs or other treatments that can help the body repair damage caused by radiation. Section 9. The future of space exploration: overcoming the radiation challenge. The quest to explore space is a testament to human ingenuity and our insatiable curiosity. But as we venture further from Earth, the challenge of cosmic radiation becomes ever more daunting. It is a fundamental constraint that we must overcome to ensure the safety of astronauts and the success of future missions. Long-duration missions to Mars and beyond will require innovative solutions to protect astronauts from the relentless bombardment of cosmic radiation. This will involve a multifaceted approach, combining advanced shielding technologies, biological countermeasures, and careful mission planning. The future of space exploration hinges on our ability to conquer this invisible threat. By investing in research and development, we can pave the way for a new era of human spaceflight, one where astronauts can explore the cosmos safely and push the boundaries of human knowledge even further. Section 10. A universe of wonders, a universe of challenges. The universe is a place of incredible beauty and wonder. It is also a place of immense power and danger. Cosmic radiation is just one of the many challenges we face as we explore the cosmos. But these challenges are not insurmountable. Human ingenuity and determination have always driven us to push beyond our limits and explore the unknown. By understanding the risks and developing innovative solutions, we can continue our journey of discovery and unlock the secrets of the universe. The future of space exploration is bright, but it will require us to confront the challenges head-on. By working together, we can overcome these obstacles and ensure that future generations can continue to marvel at the wonders of the cosmos.